My bigger 100mm chuck solves one problem, capacity, but it creates another. Every time I shift the workpiece, I lose concentricity, and when accuracy matters, that becomes a serious problem. So today, I'm fixing that. I am upgrading my mini lathe with something far more precise, an ER32 Collet chuck. If I get this right, I should be able to remove, shift or flip a workpiece and still keep it running true. But first, I need to build the backplate that makes it possible. I have been using this larger 3-jaw chuck for a while now, and honestly, it has been a huge upgrade. It gives me enough capacity to machine workpieces up to 100mm in diameter. That alone makes a massive difference whenever a part is just slightly too large for the tiny 80mm chuck that came with this lathe. But there is still one problem. A 3-jaw chuck is convenient, but every time I shift the workpiece, I lose concentricity. That means extra setup, extra dialing in, and sometimes wasted effort. What I really want is simple, repeatable precision. So I bought this, an ER32 Collet chuck. This should solve that problem completely. A collet chuck grips with excellent concentricity, and more importantly, it should allow me to shift or flip stock while keeping it centered. And since I already own ER32 collets for my milling machine from 1 to 24mm, I already have everything I need. Almost. Because this chuck is built for a 100mm spindle mount. And my lathe has an 80mm spindle mount. So before this chuck can improve anything, I need to machine a precision backplate adapter. I start with this 100mm steel round, already the perfect thickness for the job. Into the 3-jaw chuck it goes. The first step is simple. Face the mounting surface flat. I need a true reference face before doing anything else. Once that surface is clean, I move to the center. First, a center drill. Then, a pilot hole. After that, I progressively increase drill size, step by step. Each drill removes more material while reducing load on the next one. Eventually, I open it up to 13mm. Now, I can begin machining the spindle register. This is the most critical part. Before I worry about bolt holes or outer diameter or even the collet chuck itself, this rear shoulder must fit my spindle perfectly. Because once this fits the spindle correctly, I can bolt the backplate directly to the spindle itself. And from that point onward, every future cut is referenced directly from the spindle concentricity. Exactly what this entire project is about. I carefully turn down the shoulder. Then I test fit. Too tight. Back to the lathe. A little more material comes off. Then I test again. Finally, it slides on perfectly. Snug, precise, but not forced. Next, I need mounting holes. I keep the workpiece in the chuck to preserve alignment. Then move the entire chuck assembly to the rotary table. This way, I avoid disturbing concentricity. I center drill each hole first. Then drill the mounting holes. These holes will eventually be tapped for mounting. To keep the tap perfectly straight, I started with the milling machine spindle. Once the thread is aligned, I finish by hand. Now, this backplate can bolt directly to the spindle. With the backplate mounted directly to the spindle, precision really takes over. Now I face the front surface down to final thickness. Then I turn down the outer diameter to 100 mm. This matches the size of the collet chuck body. Next comes the front locating shoulder. This shoulder controls how accurately the chuck itself centers. Unfortunately, I lost the footage for that cut, but here is the result. The collet chuck seats beautifully. I also add a punch mark for orientation. That way, every time this comes off and goes back on, it returns to the same position. So now comes the moment of truth. I bolt the ER32 chuck into place. And now I need to know, did it actually work? For testing, I use the straightest round stock I have, a round high-speed steel tool bit. It may not be certified ground stock, but it should be good enough for a real-world test. I clamp it in the collet, set up the dial indicator, and rotate. Honestly, I was hoping for perfection. But this is still seriously impressive. Only 0.02 mm deviation. Not absolute perfection. But when tested with ordinary stock, that is excellent. For this mini lathe, that is a serious upgrade. More precision, more repeatability, and far less frustration. If you enjoyed this, there is another idea you might like right here. Thanks for watching.